Hello children, once again welcome back to Physics with Sanoop. See, in this video we will be discussing previous questions from the chapter Waves. See, you are supposed to watch this video with a notebook and pen, and please note down all the important points and please try to solve the questions with me. Okay, let's go to the first question. A wave traveling in the positive x direction having displacement along y direction as this is actually a wave traveling in the positive direction having maximum displacement. Okay, question you have to correct. Maximum displacement along y direction as 1 meter, wavelength is 2 pi meter and frequency is 1 by pi hertz. Okay, now see, this is the standard equation of a wave. Y equals capital A sin kx minus omega t. Okay, this capital A is the maximum displacement, or it is called the amplitude. Here it is given as 1. Okay, and k is called a propagation constant. It is 2 pi over lambda, and lambda is given as 2 pi. So 2 pi over 2 pi, that will be 1. And omega is angular frequency, 2 pi nu. Nu is given as 1 by pi, so it will be 2. Okay, we have the values of A, K and omega. So you have to simply substitute the values in this general equation. So y, A is 1. So sin k is, that's also 1. So it will be x, and omega is 2. So x minus 2t. So this must be the correct option. Okay. Now let's see, a transverse wave is represented by y equals A sin omega t minus kx. Okay. For what value of the wavelength is the wave velocity equal to maximum particle velocity? See, whenever a wave is propagating through a medium, see, the particles of the medium will be executing SHM. Okay, when a particle is in simple harmonic motion, its velocity will be maximum at the mean position. As it moves from mean to the extreme position, its velocity will go on decreasing, and at the extreme position, velocity will be 0. Okay, see, this is the mean position. Here the velocity is maximum. Okay, velocity decreases and becomes 0 at the extreme, then increases and becomes maximum at the mean position again. Okay, go on decreasing, and again its velocity falls to 0 at the other extreme. Okay, now particle executing simple harmonic motion is moving with the variable speeds. Its speed is maximum at the mean position and 0 at the extreme. Okay, whenever a wave is propagating through a medium, wave motion means that is the energy propagation, and that motion takes place with a constant speeds. Okay, it's called wave speed, and it is omega by k. Okay, wave speed is omega by k. And see, the particle moves with variable speed, and its maximum value is omega a. Omega a. Okay, here we have wave velocity equal to maximum particle velocity. So omega by k equal to omega a. Omega can be cancelled from both sides. Okay, so k we have 2 pi by lambda. And here we have 1 by k, means lambda by 2 pi, that is equal to a. So lambda will be 2 pi a. Okay, so lambda, that is equal to 2 pi a. Now the ratio of the maximum particle velocity to wave velocity, see, this is an important ratio, and it is represented by Ka. Ratio of the maximum particle velocity to wave velocity, that is Ka, where k is 2 pi by lambda and a is the amplitude. Here it is given that maximum particle velocity and wave velocity are equal, so the ratio will be 1. So you will get Ka equal to 1. K is 2 pi by lambda, a, that is 1. So lambda will be 2 pi a again. Okay. And next, a wave in a string has an amplitude 2 centimeter. Means it is actually 2 into 10 raised to minus 2 meter. That I have written 0.02 meter. Okay. The wave travels in positive x direction. Children, if the wave is propagating along positive x direction, there will be minus sign in between. Okay, kx minus omega t or omega t minus kx means the wave is propagating along positive x direction. If there is plus sign in between omega t and kx, then the wave is propagating along negative x direction. But here it is given that wave is propagating along positive x direction. Then there should be a negative sign in between kx and omega t. Okay, so we can see the answer cannot be the option B because there is plus sign in between, and also this one D. Okay, so the answer will be either A or C. Okay, now see a positive x direction with a speed of 128. Speed is given as 128 meter per second, and it's noted that 5 complete waves in 4 meter. Means 5 lambda equal to 4. And lambda will be 4 by 5. Now k is 2 pi by lambda. Or we can say 2 pi divided by 4 by 5. Or this is 5 pi by 2. Pi is 3.14. So if you put the value 3.14, you will get 7.85. And the speed is omega over k. Okay, so omega will be kv. K we have got 7.85. And v is 128. Okay, 7.85 into 128, that is 1005. This is omega and this is k. Okay, so it must be kx minus omega t. Okay, kx 7.85 x minus 1005 t. So this must be the correct option. Now the wave described by 0.25 sine 10 pi x minus 2 pi t, where x and y are in meters and t in seconds, is a wave traveling along. See, as there is negative sign in between kx and omega t, it must be traveling along positive x direction. Okay, and now it's given that it's frequency and wavelength. We have to find out. Okay, k, it is 2 pi by lambda and it is given as 10 pi. Okay, so 2 pi by lambda equal to 10 pi. So lambda will be 2 by 10 or 0.2. Okay, omega is given as 2 pi. Okay, so omega 2 pi nu. Okay, so and it is given as 2 pi, so nu will be 1 hertz. Frequency is 1 hertz, wavelength is 0.2 meter, and wave is propagating along positive x direction. How do you know that it is propagating along positive x? If there is negative in between kx and omega t, then it is propagating along positive x direction. If there is positive here, then it is propagating along negative x direction. Okay, so this one must be the correct option. Positive x direction with frequency 1 hertz, wavelength 0.2 meter. Okay, a transverse wave propagating along x-axis is represented by, see, 8 is the amplitude and 0.5 pi, that is k, and 4 pi, that is omega. Okay, the speed of the wave is actually omega by k. Omega we have 4 pi and k we have 0.5 pi. Okay, so it will be 4 by 0.5, that is 8 meter per second. So this must be the correct option. Now the equation of a transverse wave traveling along positive x-axis with amplitude 0.2 meter, velocity 360 meter per second, wavelength lambda equal to 60 meter can be written as. Okay, now see, this is the general equation. A sine 2 pi, then nu t minus x by lambda. Okay, so we have to get nu. Nu is actually v by lambda. Okay, v is given as 360 and lambda is 60. So nu will be 360 by 60, that is 6. Okay, so here it must be 60. Okay, and here it must be x by 60, lambda. Okay, 60 minus x by 60. So this must be the correct option. Right? See, a transverse wave is represented by y equals y0 sine 2 pi by lambda, then vt minus x. Okay, this is actually vt, velocity. Children, only similar quantities can be subtracted and added. This x being a distance, okay, that can be subtracted only from another distance. So this must be velocity into time. Okay. For what value of lambda is the maximum particle velocity equal to 2 times the wave velocity? See, the ratio of maximum particle velocity to wave velocity, that is very important, and it is Ka, where K is the propagation constant and A is the amplitude. Here the amplitude is given as y0. Okay, see Ka, and maximum particle velocity is twice the wave velocity. So V P max by V wave, that is equal to 2. Okay, so 2 pi divided by lambda, amplitude is y0, that is equal to 2. 2 on both sides can be cancelled. So we will get lambda equal to pi y0. Okay, lambda equal to pi y0. This must be the correct option, right? Now the temperature at which the speed of sound becomes double as was at 27 degrees Celsius. See, speed of sound through a gaseous medium T, it's given by V equals root of gamma RT by M. where m is the molar mass, r is universal gas constant, gamma ratio of specific heats, and T is the absolute temperature. Okay, initial temperature T is given as 27 degrees Celsius and it is equivalent to 300 Kelvin. Okay, now here we can say V proportional to square root of temperature, and temperature will be proportional to square of the speed, T proportional to V square. So T dash by T will be V dash by V whole square. Okay, here the velocity gets doubled. Okay, so the T dash must be equal to 4T. Initial temperature is 300 Kelvin. So final temperature will be 1200 Kelvin. Okay, and we have to convert that final temperature 1200 Kelvin to degrees Celsius. For that you have to subtract 273. Children, never subtract 273. Instead of subtracting 273, you subtract 300. After that you add 27. So from 1200 if you subtract 300 you will get 900. After that you add 27. So it will be 927. Okay, 927 degree Celsius. Okay, next velocity of sound waves is 330 meter per second. For a particular sound wave in air, path difference is 40 centimeter, means 0.4 meter, equivalent to a phase difference of 1.6 pi. Okay, frequency of this wave is. See, this is the relation between phase difference delta phi and path difference delta x. Delta phi equal to 2 pi by lambda into delta x. Delta phi is given as 1.6 pi. And path difference delta x is given as 0.4. 0.4 into 2, that is 0.8 pi. Okay, so lambda will be 0.8 pi divided by 1.6 pi. That is 1 by 2. Okay, speed is given as 330. We have to determine frequency. V by nu, 330 divided by half. So it will be 660 Hertz. So this must be the correct option. Okay. Now let's see what we have next. The transverse wave represented by the equation y equals 4 sine pi by 6. Pi by 6 is actually 30. So 4 sine 30. Sine 30 is 1 by 2. So amplitude is actually 4 sine 30, that is equal to 2. But here it is given that amplitude is 4. That option is not correct. Okay. Now see, the general equation is y a sine kx minus omega t. What stands for k? K is actually 3. Okay, so this k equal to 2 pi by lambda, that is equal to 3. Okay, and omega, what stands for omega? Omega, that is 15. And the speed of propagation of the wave is omega by k. Okay, so omega by k, 15 by 3, that is 5. Speed of propagation is given as 5. Okay, and C, that's fine. Okay, C is the correct option. And wavelength, see, what would be the wavelength? See, 2 pi by lambda is 3. So lambda will be 2 pi by 3. Here it is given as 4 pi by 3. Okay, now see, we have omega, that is 15. And period will be 2 pi by omega. So 2 pi by 15. But here it is given as pi by 15. So only the option C is correct. Right? Next, the equation of a progressive wave is given by 4 sine pi t minus 5 minus x by 9 plus pi by 6. Which of the following is correct? Okay, see it. See, this is the standard equation. Okay, see what stands for omega t. Omega t is pi t by 5. So omega will be pi by 5. Okay, what stands for kx? It is pi by 9x. So k is pi by 9. And speed will be omega by k, that is pi by 5 by pi by 9. Or it is 9 by 5. Or 18 by 10. That is equal to 1.8 centimeter per second. But the speed is given as 5 centimeter per second. So that is not true. Okay. Now omega we have pi by 5. And k is 2 pi by lambda, that is equal to pi by 9. Okay, pi and pi can be cancelled. So you will get lambda equal to 18. So lambda equal to 18 centimeter. That is true. Okay. Now the amplitude is actually 4 centimeter. But it is given as 0.04 centimeter. That's also false. Okay. See this one, frequency. Omega is pi by 5. And frequency will be omega by 2 pi. So when you divide this pi by 5 with the 2 pi, you will get 1 by 10. Or it is 0.1 Hertz. Here it is given as 50 Hertz. Only one option is correct. That is the option B. Now the ratio of frequencies of fundamental harmonic produced by an open pipe. See, fundamental frequency of an open pipe is V by 2L. Okay, to that of a closed pipe, that is V by 4L. So V by 2L divided by V by 4L, that is 2:1. Okay, so this one 2:1, right? Next, an organ pipe filled with gas at 27 degrees Celsius resonates at 400 Hertz. It's a fundamental mode. Okay, if it is filled with the same gas at 90 degrees Celsius, the resonant frequency at the same mode will be. See, resonant frequency for an open pipe is V by 2L. Okay, and V is given as root of gamma RT by M. Children, frequency directly proportional to speed, which in turn proportional to square root of temperature. Okay, we can say frequency directly proportional to square root of temperature. So nu dash by nu will be root of T dash by T. Okay, T dash final it is 90. So 273 plus 90 means that will be 363. And initial temperature 27 degrees Celsius, it is equivalent to 300 Kelvin. So 363 by 300, that is 1.21 under root. So it is 1.1. Okay, so we will get nu dash equal to 1.1 nu, or it is 1.1 into 400 or 440 Hertz. This one. Okay, now let's see if the initial tension on a stretched string is doubled, then the ratio of the initial and final speed of a transverse wave along the string is. See, V equals root of T by mu, and we can say velocity directly proportional to square root of tension in the string. So V by V dash, that is equal to T by T dash. Final tension is twice the original tension, so it will be 1 by root 2. So the ratio will be 1:√2, this one. Okay, now let's see what we have next. In a guitar, two strings A and B made of same material are slightly out of tune and produce beats of frequency 6 Hertz. When tension in B is slightly decreased, in a guitar, two strings A and B made of same material are slightly out of tune and produce beats 6 Hertz. So the difference in frequencies of the two strings is 6. Okay, and the frequency of A is given as 530. Okay, A is 530. The difference between A and B is only 6. Okay, so the frequency of B will be either 6 Hertz less or 6 Hertz more. Okay, now when the tension in B is slightly decreased, suppose this is the frequency of B. When the tension is reduced, see, the frequency will decrease. Then the difference between these two will get reduced. But here it is actually increased from 6 to 7. See, if this is the frequency of B and if its tension is reduced, it will come down. So the difference between these two will get reduced. But here it is actually increased. So this is not the frequency of B. Now let's check this one. Okay, it is 524. When the tension is decreased, see, the frequency will get reduced. Okay, it also will decrease. So the separation or the difference between these two will increase. So the original frequency of the other string should be 524. Okay, 524 Hertz. Okay. Now the fundamental frequency in an open organ pipe is equal to third harmonic of a closed organ pipe. See, fundamental frequency of an open pipe is V by 2L and fundamental frequency of a closed pipe is V by 4L. And its third harmonic will be 3V by 4L. Okay, so 3V by 4L for closed LC. Fundamental frequency of open, that is V by 2LO. These two are equal. So we will get LO equal to 2 by 3 LC. Okay, length of the closed pipe is given as 20 centimeter. Okay, so 2 into 20, that is 40, divided by 3, that will be 13.3 centimeter. Okay. Next, the two nearest harmonics of a tube closed at one end and open at the other end are 220 Hertz and 260 Hertz. Closed at one end and open at the other end. Only the odd harmonics will be present. Okay, so the frequency in the nth mode will be 2n-1 V by 4L. Okay, and see, in the n plus 1th mode, it will be 2n plus 1 into V by 4L. Okay, and the difference, see nth mode will be this one and n plus 1th mode will be, see, 2n plus 1, okay, into V divided by 4L. Okay, this is nth modes. Okay, and see, this will be the n plus 1th modes, right? Okay, and the difference will be, see, 2n plus 1 V by 4L minus 2n minus 1 V by 4L, that is 2 V by 4L. Okay, or it will be V by 2L. Okay, now see, here we will get 260 minus 220, that is 40. So 2 V by 4L is 40. So V by 4L will be 40 by 2 or 20 Hertz. Okay, that is the fundamental frequency. So for 40 Hertz. Now a uniform rope of length L and mass M1 hangs vertically from a rigid support. Okay, a block of mass capital M is attached to the free end of the rope. Okay, see, a transverse pulse of wavelength lambda 1 is produced at the lower end of the rope. The wavelength of the pulse when it reaches the top of the rope is lambda 2. The ratio lambda 2 by lambda 1. See, at the lower end, the tension will be M2G, because at the lower end only the weight M2 is hanging. But at the top, see, the whole rope and M2 will be hanging. So the tension at the top of the rope will be M1 plus M2 into G. Okay, so here the speed of propagation of a wave through a string is given by V equal to root of T by mu. So when the tension is different, speed will be different. Okay, so speed at the lower end and upper end will be different. Okay, so as the wave propagates from the lower end to the upper end, frequency will not change. As the speed changes, the wavelength also will change accordingly. Okay, now the frequency at the bottom and at the top, it should be the same. Okay, so lambda to V is actually nu lambda. As nu is same throughout the rope, okay, we can say V proportional to lambda. So lambda 2 by lambda 1 will be V2 by V1 and it is root of T2 by T1. Okay, T2 will be M1 plus M2 into G and T1 will be M2 into G. Okay, so G and G will get cancelled under root M1 plus M2 by M2. M1 plus M2 by M2. Okay, so this must be the correct option. M1 plus M2 by M2, right? Now 3 sound waves of equal amplitude have frequencies n minus 1, n and n plus 1. Okay, they are superimposed to give beats, number of beats produced per second. Okay, see, when this pair is superimposed, difference is 1, so the beat frequency will be 1. So the beat period will be reciprocal of frequency, that is 1. Okay, when this pair is considered, difference is 1, beat frequency is 1, beat period is also 1. But when you consider this pair, the difference is 2. So the beat frequency will be 2 and beat period will be 1 by 2 or 0.5 second. So this pair will produce a beat in every 0.5 second. Okay, and this will produce a beat in every 1 second. Okay, so at a certain moment, see, this pair and this pair together will produce beats. But all those beats will occur at the same instant. So we can hear a sound of, see, high intensity or a louder voice we can hear. Okay, see, all the 3 pairs will produce beats. After half a second, only this pair will produce a beat. We can hear a beat, but it will be of smaller intensity. Okay, again, see, another beat after half seconds. So in every half second we will hear a beat. Okay, and see, every alternate beat will be of high intensity, but we can hear a beat in every half second. So beat period is half second and beat frequency will be see, 2 Hertz, this one. Now a source of unknown frequency gives 4 beats when sounded with a source of frequency 250 Hertz. So the known frequency is 250. Okay, when it is sounded with another source, 4 beats will be produced. So the difference is 4. So nu dash can be 250 plus or minus 4. Means it can be 246 or 254. Okay, the second harmonic of the source of unknown frequency means 2 nu. See if nu dash, if nu dash is the unknown frequency, its second harmonic means 2 nu dash. Okay, that produces 5 beats per second when sounded with a source of 513 hertz. So 2 nu dash will be 513 plus or minus 5. Means 513 plus 5, that is 518. 513 minus 5, that is 508. Okay, nu dash can be either of these, and 2 nu dash must be one among these. Okay, see, this thing should be twice of this one. Okay, so there is only one pair that is like this. Nu dash is 254 and 2 nu dash is 508. Okay, so the original unknown frequency must be nu dash, that is equal to 254 hertz. This one. Okay,